It makes me reshare the screen. Okay. Okay, can everyone still see the screen?
Yeah.
Okay, good deal. All right, well, appreciate everybody getting on today. Thanks for letting us do this for you. My name's Jamie McCutcheon with Rymar Waterworks. Let's go. Just a little bit about me first. I am a Clemson grad, and for you Ohio State people, y'all kicked our butts last year, so congrats on that. And you're looking a lot better than us this year. So I'm a civil engineer. I've been doing engineering for about 26, 28 years now. Had my own engineering company for almost 20 years and was acquired by a larger company about 3 years ago. South Carolina adopted requirements for skimmers in 2013. And I invented the Marley float skimmer then, basically based on hearing a lot of concerns from contractors and engineers about products that were on the market. We started off as SW Products. We rebranded as Rymar Waterworks in 2018. And like I said, I am a licensed engineer in South Carolina, North Carolina, and Georgia. This is just for you guys and girls that are on here. So, along the way, please feel free to stop me and ask any questions. I'm going to try to make this pretty technical for you. So hopefully you'll find some tips that will help you in the design and permitting process. But please feel free and stop me anytime. A little quick story too. Most people look at it, the Marley float, and just think that's kind of a strange name for a product. It came about in 2013, or just before 2013. South Carolina was adopting requirements to require skimmers. We were updating the construction general permit, and I was hearing a lot of complaints from other contractors, engineers about some of the issues with current products at that time. And our daughter had a bad night in December 2012, and she's a little ruder. She was 11 years old at the time, which was unusual for her to want to sleep with my wife and I, but she did. And because I had knees and elbows in my back all night, didn't sleep very well, and ended up thinking about an idea for a skimmer. I actually got up and sketched it out. We ended up making it. And when it was time to name it, it seemed fitting that we give our daughter Marley credit. So that's why it's called the Marley float, inspired by our daughter keeping me up one night. So this webinar, we're going to focus on a few things. First, we're just going to talk about skimmers. I'm sure you're used to them. You're in Columbus, so they're fairly common there. We'll do a quick overview of the fundamentals of basin design. We'll get into some specific Ohio EPA requirements and kind of their design tool. And then we're also going to talk about advanced skimmer modeling in HydroFlow and HydroCAD, and reasons why you may want to consider that, and also consider permanent use of a skimmer in your basins. So you've all seen previously what we used to use instead of skimmers. You had a perforated riser, had a hole at the bottom, and that hole sucked out a lot of mud during the sediment basin stage. You had a riprap or stone check dam in front of it, but those things just don't work quite as well as skimmers do. With the advent of skimmers, which started maybe 10-15 years ago, it's designed to accomplish the surface withdrawal, which is required in your permit. And so withdrawals from the surface or near the surface allows more time for the mud to settle, and ours takes in water from about 8 to 16 inches below the surface. One advantage of this is it does exclude any trash or floating debris. Even if you had a diesel spill during construction, that's at the surface of the basin. There are a variety of skimmers out there. The Faircloth is probably the most common. He's been around the longest and kind of helped get this product started and noticed by EPA. There's Erosion Supply, there's IES, there's Marley Float. There are probably a few others out there now, but these are kind of the most common that you'll see. As I mentioned, in your construction general permit, EPA now has this requirement for most states, and it basically says when discharging from sediment basins, utilize outlet structures that withdraw water from the surface unless infeasible. And most states also include a note that they believe the circumstances in which it's infeasible to design outlet structures in this manner are rare. We do get asked a lot of questions about freezing and cold weather. And we'll talk about that a little bit during this as well. But in general, because ours does take from below the surface about 6 inches or so, unless you get more than 6 inches of ice, it's going to continue to function pretty well. And because of our construction, we don't necessarily recommend it be taken out during winter unless you're just experiencing some really extreme freezing. So I know Kimley Horn has offices across the country. Skimmers are currently required in about 30 states. EPA continues to add more and more requirements for states to have skimmers. However, states definitely enforce this differently, and even MS4s within the states. Columbus and Cleveland are probably two of our best markets for our product. However, we don't sell very many in Cincinnati or Toledo or some areas outside of the Columbus and Cleveland areas. Starting to see more there, but it's definitely taken those MS4s longer to start enforcement of that than the Columbus and Cleveland area did. So, the fundamentals of sediment basin design are really simple. It's basically volume, time, and flow rate. So, the volume is just based on an area, what the area is going to the basin, whether it's total area or disturbed area, depending on the state. Some states have regulation require 1,800 cubic feet. Others require 3,600 cubic feet. Others have some different requirements. But, simple math, acreage times whatever the requirement is equals your required volume. And then Ohio also has a requirement to have the permanent pool that you're familiar with. That's not in every state. Some states have that, some don't. But one thing to really highlight here is when you're sizing your skimmer and outlet, you need to use the required volume and not your actual volume to size the skimmer. And we'll talk about that in a little more detail shortly. So the second fundamental is dewatering time. Most states, the standard is 2 to 5 days. A lot of people shoot for 3 days. Ohio allows up to 7 days, 2 to 7 day range. We typically recommend trying to stay in that 2 to 3, not over 4 day range, just so that the basin drains out before you have your next thunderstorm and have it overtop, the spillway. And then once you have your volume and time figured out, it's pretty easy to figure out your flow rate. It's just your volume divided by your dewatering time. So in our example, if we assumed a 28,000 cubic foot required volume, you try to drain it in 2 days, you want a maximum flow rate of 14,400 cubic feet per day. If you want to, extend it to 5 days, go down to 5,760. And if you went out to 7, it'd be even lower. It should be around, 4,000 cubic feet per day. So you can see it's a pretty big range that you've got that your skimmer can work within. And one thing to point out for your client and contractor, if you do extend the time frame, you can often, use a smaller and therefore less expensive skimmer. Although, these are not really expensive items, so it's not going to save a lot of money, but it is something to keep in mind. So one thing that is not well known is that skimmers are not constant flow devices. Although they do have relatively constant head, testing has shown that they actually do have a flow rate curve. This is some testing that TRI Environmental did. They tested 3 different types of skimmers. Ours was included in this, as was Faircloth. I'm not sure what the other one was. But you'll see here, their test tank is 4 feet deep. So it goes from 1 to 4 feet of depth. At 1 foot of depth, 2 of the skimmers were flowing about 37 CFS, or excuse me, GPM. This is in GPM. One is in 70 GPM, so nearly double the flow rate. And then all the skimmers had an increase of about 25% flow rate from 1 to 4 feet. And again, 2 of them were similar, 47 to 53, and the other one is nearly double at 90 GPM. So if you simply specify a 3-inch skimmer and nothing else, you may or may not get the flow rate that you're looking for. This just for an example, this is the flow rate curves for some of our skimmers. You can see they all start at 0 and have a slight increase up to 4 feet. Some of them have a more pronounced increase, but all of our skimmers have been third-party tested to verify the flow rates as the depth of the tank or pond increases. And then obviously we're focusing on Ohio today, but I think engineers sometimes find it interesting to see what the different requirements are in different states. So, each state typically has a basin volume specified. Some specify the volume based on disturbed area. Some of it specifies based on total area. And I apologize if you hear the dogs barking, got somebody at the door. So Kentucky has a requirement that is soil type dependent. So they actually make you calculate your basin volume based on your soil type. But again, in Ohio, it's 1,800 cubic feet per acre, and that's your total acreage flow into the basin. And then an additional 1,000 cubic feet per acre per disturbed area, per disturbed acre, that is below your invert for your sediment storage. Surface area requirements are pretty consistent. There's two different formulas, but they come out about the same. I believe in Ohio, you don't have a surface area requirement. You just have a maximum depth of 5 feet. Principal spillways range from the 2 to 10-year storm typically. And the principal spillway is considered your skimmer, maybe another orifice in your riser in top of the riser structure. And then typically the basin would also have an emergency spillway designed for that, ranges from 10-year to 100-year, with Ohio being a 25-year storm event. It isn't interesting to see where skimmers are required. In a lot of cases, it's required by the state at 10 acres or greater, although some MS4s may have more strict requirements. Again, Ohio is a 10 acres or greater, but we typically see them on smaller basins. And the way the CGP is written, it's really any sediment basin that has a true outlet structure. If it's a sediment trap that has like a rock outlet, obviously you're not putting a skimmer in there, but basically anything that's got a riser, designed orifice and stuff is going to see a skimmer. And again, the dewatering time ranges 2 to 5 days is kind of a typical. Ohio allows a 2 to 7 day, so does Pennsylvania. And then again, Kentucky actually requires you to go through a calculation to prove you got 80% trapping. So we'll jump into the Ohio specifics. So a couple of these slides are taken off the Ohio EPA website. So you're probably familiar with that, but just in case you're not, they have a design tool that's in place there. You go to their website, go down to their sediment basin compliance spreadsheet, which is under the construction activities tab. And then one thing that Ohio does point out is they do not require or recommend any specific type of skimmers. I know in the design manual, the Faircloth is listed by name, which I believe they're finally updating that manual and just making sure people know that you don't have to use a specific skimmer. They don't endorse or approve any proprietary devices. We've been asked many times if our device is approved by Ohio EPA, and we've got confirmation that it's acceptable. But like I said, they do not necessarily endorse or approve any specific skimmer. They leave it up to the engineer. So they have, again, the regulatory guidance, so all the standards, which we've already talked about. They do have a higher volume in certain watersheds, or higher volume of, volume requirement for the basin in certain watersheds. Anyway, I'm sure you're all familiar with these requirements, but again, they're on the website if you're not. So then they go through the sediment basin volume requirements. They'll let you put this in. They calculate your disturbed area, your total drainage area and your disturbed area. And then they also give you the minimum volumes for each based on the inputs you put in there. They let you go through your stage storage relationship. So put in your basin information. So your elevation and your area at each elevation. Again, you've got your sediment storage, you've got to calculate it, and then your dewatering zone before you hit your secondary outlet. Their default is the Delaware Dot Skimmer. We see this on some plans occasionally. The feedback from contractors is they would rather just purchase one. These were intended to kind of be made, by the contractor. The biggest difference in this product is, with your skimmer here, you've got an orifice on this end cap. So the head on this orifice does vary based on the depth of the pond. And so the flow rate really does vary more significantly based on the depth in your pond. And you can get, a 2-inch orifice here is going to have a lot higher flow rate than a 2-inch skimmer. So, you have to calculate the head and go through the calculations to determine what size orifice you need to be for that pond. They have options for the erosion supply skimmer, the Faircloth skimmer, the IAS, and they have included the Marley float. So just seeing that Ohio EPA is aware of us and specifically does allow the Marley float to be used. So we developed a design tool that's available for download with feedback from Ohio EPA, Summit County, City of Columbus, City of Cleveland. Had a lot of feedback from the Ohio regulatory community on this. The specific thing they told us is they see engineers using more than the required dewatering volume. So if you've got a basin that's going to be your permanent pond, you may have a volume in that pond that's 2, 3, 4 times what's required for your dewatering volume. And if you size your skimmer based on that higher volume, one, you're going to end up with a much bigger, more expensive skimmer. But more importantly, from the regulatory side, you're going to discharge the required volume too fast. So you're going to let water out faster than you need to. It's not going to hit the trapping efficiency that they're looking for. And so they really focus on trying to hit this required dewatering volume. So the way our tool works is you plug in your information, date, project name, location, your company, the engineer. You have inputs here. So this is maximum time to drain, 7 days, minimum time, 2 days. Your pond depth, that's very important. That's your dewatering zone. So that's from the invert of the skimmer up to the depth to reach your required volume. Then we have a top length and width and a bottom length and width. Now we recognize that there's no or almost no basins out there that are square or rectangular. So use your engineering judgment to adjust these numbers so that you get to a calculated pond volume that's within reason of your required dewatering volume. We typically recommend within 5%. Again, we're trying to hit a 2 to 7 day range. So if you're off 500 or even a couple thousand cubic feet, it's really not going to change that. So, just get within reason, but you don't want this calculated pond volume to be, double your required volume. So you plug that in and back up. And then the spreadsheet here has calculations for all of our skimmers and all of our orifice configurations. Once you have that in place, there is a skimmer report page tab down at the bottom here. Click on that, and then it'll take you to a one-page sheet that's designed to be put either on your plan set or in your stormwater report. So again, we highlight the required dewatering volume and the calculated pond volume to make sure that those are close. We calculate the minimum flow rate for the maximum time, and then the maximum flow rate for the minimum time. And then because it is our tool, we show every model of skimmer with every orifice configuration, what the drawdown time in hours would be for each one of those. And then if it's acceptable, if it falls within that required drawdown time range, it'll come out and say, yes, it's acceptable in here and list it. You then pick which one you would prefer to see. Again, we typically recommend shooting for a 3-day time frame, so around 72 hours. This one go down to a 2-inch skimmer at 141 hours. That's getting out over 4 days. That may be fine if you'd like to go there. We'd probably suggest, going up to the 3-inch and trying to hit around that 72 hour range in most cases, but that's totally up to the engineer, just within the required time frame. So then you just take that information, plug it back into the Ohio EPA sheet. They've got some details and pictures from our old models, which are fine. We sent them some new information to update that, but we'll go through that shortly as far as our skimmer goes. And then you can print out, their design tool and our page, to be included in your SWIP or on your plan set, so that the review agency has everything they need to show that how you came up with the skimmer that you put in here, was based on these calculations. So hopefully that's pretty simple as far as the basic sediment design goes. Like I say, if you do have any questions or if I'm going a little fast, just stop and ask me. We have also created a couple of generic sediment basin details. We have them with and without the permanent pool, and we have them with and without a riser structure. These are all available for download on our website in CAD or PDF. You can edit as you need to. Edit the Skimmer Sediment Basin design criteria here. Edit that dewatering volume if needed, the sediment storage, etc. So one thing to point out is we specify a minimum and maximum dewatering time on this detail. So you've got that on your plan set. And then down at the bottom, you've got the specific basin information, for each basin on the site. So again, this is editable. If you need to add, more basins in it, you can, but it's got your sediment storage volume, required versus provided. And again, in this case, provided needs to be more than required. Dewatering volume, again, required and provided. Your total drainage area, disturbed area, the queue that your basin, your sediment basin design on, whether that's the 10-year or 2-year storm, depending on your area. Basin area, in your case, you just got a basin depth requirement, but most places have a basin area requirement. And then basic pond information. So the bottom of the basin, the outlet, the barrel size going out, your top of your riser, emergent spillway width. And here you go with the skimmer size. So that would be, say, a 3-inch skimmer orifice diameter. Say that's a 3-inch or 2.5-inch. Skimmer type. So you can put in here Marley, Faircloth, Erosion supply, whatever it would be. Is an equal allowed, yes or no? Typically that's going to be yes, but there are some areas where that would be a no because you have to hit very specific flow rates. And you're trying to hit something that's more precise, or you just, as an engineer, may decide you prefer not to have a different skimmer. You want what you spec. And then specify your minimum and maximum flow rate here based off your minimum and maximum dewatering time. What that does is it lets the reviewer approve that up front. And then if the contractor does have a different skimmer or different size skimmer he wants to use because he's left over from another job, as long as that flow rate falls within that min and max, it should be a simple shop drawing type review and not a full review going back through the process, because reviews already approved that range rather than a specific time. So that's one thing really try to focus on is getting a range of time approved initially, rather than trying to hit an exact 72 hours or exact 48 hours, because every skimmer flows a little bit differently, and take advantage of that range that you're allowed to do. So a couple of things to point out. Got a couple of photographs here. Again, yours is going to have a permanent pool, so it wouldn't really look like this. But in areas where you do have a dry basin that you've designed, what we see often is they set the stone pad on top of the dirt once it's graded, and you end up with a slight permanent pool anyway. Unfortunately, it's usually like a 4 to 6 inch permanent pool, which can be a mosquito factory. And so we try to tell contractors in areas where they have a dry basin, go ahead and set this stone down a little bit, excavate out, create a little bit of a pit. So the only place holding water is right around the skimmer. The rest of the pond can stay dry in times when it's not raining and get vegetation established. We've seen some really bad installs. This is one of the worst. Here you've got a skimmer with no flexible coupling. I'm not even sure how they attached it there. It's interesting that on this side, they've got this valve wide open, so all the water's short circuiting anyway. They did put in this check dam and wash stone here. Often you really don't need that as much with skimmers because you're going to be withdrawing from the surface anyway. Not necessarily a bad idea, but if you do it, you want to put it far enough away from the skimmer that it's not causing it to be offset, when you do it. We also seen contractors install ours upside down. I'm not sure how they get that wrong, but anyway, they do. But in this case, You also have the flexible coupling here, and you have such a short piece of pipe, unless that pond depth is only 6 inches, you know, that skimmer is not going to float very high. So we try to make it, you know, very simple for contractors to install, but unfortunately we just have seen some bad things in the field. Skimmers are not maintenance free. You know, this is one that was on a project that we were doing the engineering on, and when you see vegetation growing out of the skimmer, it's probably a sign it needs some maintenance. This one happened to have a big root ball in it. Also, you can see here, you got, you know, dirt's accumulated under the pipe, so it's causing more water to stand in the pond than normal. So definitely time to do some maintenance on that basin. So, all right, so that's kind of the basic of the sediment basin side. Now we're going to jump into more of a permanent use discussion. So I'm not sure if any of you ever have considered using skimmers permanently. There's a couple of reasons to do that. Number one is you get the benefit of the surface withdrawal. So just like during construction, you know, post-construction, you give more time for the pollutants to settle and go out. The other big one is maintenance. You know, right now, I'm sure for water quality, you end up, especially on smaller sites, having to do some really small low flow orifices. And then you're trying to figure out some way to keep those clean and keep them getting clogged up so that the pond functions the way it's supposed to. Well, a 2-inch orifice with, you know, 2 or 3 feet ahead flows very similar to maybe a 4 or 5 or even a 6-inch skimmer orifice with, you know, 4 to 6 inches ahead. So you get the advantage of a larger orifice that's less prone to clog. You also get the advantage of being able to get to it. If the skimmer does clog, you know, hopefully they've tied a rope to it. You just pull the rope to the side, shake off the leaves or debris, and it's functioning again. Versus if you've got a really small orifice that's 3-4 feet below the water level, very hard to get to. So we're going to look at 2 specific places where we have retrofit ponds for skimmers for maintenance. So this first pond was a car dealership. The pond had not been maintained in about 15 years. And so it originally was basically a forest. We worked with a contractor to clean it out. When we got done, you could see these holes in it here, but we couldn't find a low flow orifice anywhere. You see it's a really lot of muck and debris going to that. So it was, you know, clogging it up often. What we found was there was a 2-inch orifice 6 feet below the muck that's in this basin. So basically below this level here. And we worked with the county and the owner. We redesigned the basin. We designed it to utilize a skimmer as the permanent outlet instead of that 2-inch orifice. We closed in these orifices in the riser, added some higher, to kind of redesign the pond. Fortunately, the pond had some excess capacity. And we've been monitoring that. We monitored it for the first 12 months every month. And then we continue to monitor it as we go along now and continue to use it as a testing ground for our skimmers. And that skimmer's been in place now for, I guess, about 7 years. We put it in 2014. So one of the best examples of the field proven, you know, non-clogging, you know, maintenance benefits. This basin, about a year after we put the skimmer in, the new owner was doing maintenance. So they had landscapers go out and cut it. Well, they didn't get all the vegetation out that they had cut, and they had a 5-inch rain in just a few hours. So the water got all the way to the top of this riser. It's kind of hard to tell in this picture, but that's about a 12 to 14 foot tall riser structure there. But the skimmer did not clog, you know, was able to drain the basin, the pond down, even with all this, you know, massive amounts of debris in there, and we'd put a 2-inch orifice back in, and it had clogged, you know, getting down to that, you know, some 6-8 feet deep in water, and trying to get to a 2-inch orifice would have been nearly impossible. So, and even dangerous, you know, probably had to go in through the top of the riser to do it. Another example, we did a apartment project in Charlotte. We worked with a contractor to help clean it out. We found this head wall that was basically buried. You can see where the debris line was. I'm not sure how it was even draining at all, but it had a natural stream flowing through the area. Cleaned it out, put a riprap around it, got it clean, but it's a very natural area. And after every rain, you get a ton of natural debris, sticks and leaves and just trash flowing down in this thing. So it kept clogging it up. And sometimes it would clog it completely and it would stay wet for several days because they couldn't get to the head wall to get it cleared out. So we redesigned this one, put in a riser structure, and then put in a skimmer to help with the low flow. And in doing this, we also, in Charlotte, they have a stormwater utility fee credit program. And we were able to get a 95% credit for this site with that program, which equaled about $26,000 a year in savings. So that credit paid for this work in about 2 years, I think, total. Is what it took to recover that. We continued to monitor this one. We kind of learned some things over the years. This is our old model skimmer. And one thing we learned is we put an HDPE pipe between the outlet structure and the skimmer because we're worried about UV degradation of the PVC. Well, HDPE will bow or bend easier than PVC. So again, this is in Charlotte, it gets hot. So sometimes that HDPE pipe would tend to bow. So we've replaced that. We just recently replaced it with our new model skimmer. So very similar flow rate on it to the old one, and are putting it out there now, and it's functioning very well. But we continue to use that kind of as a proving ground, testing ground for our new models as well. So if you're going to use a skimmer post-construction, you've got to model it in your HydroFlow or Hydrographs or HydroCAD, whatever your hydrology software you're using, to make sure you're handling it. So there's two ways to do that. One, you can continue to use a low flow orifice and model it that way and just use a skimmer with a higher flow rate and let the skimmer feed that and the flow control be by the smaller orifice. Or what we recommend is let the skimmer do the flow control and just model it to show you how you're doing it. So this is going to be HydroFlow Hydrographs. I know you're probably familiar with that since it's built into AutoCAD. But this is a specific site we did in the city of Greenville. The city of Greenville does require quantity control during construction. So we had to, this was actually a sediment basin, but we had to model what the skimmer would do to show the city that we were meeting our quality control requirements during construction. So we had about a 5-acre site, 5.5. We were disturbing about half of that and going to a basin and then discharging. So this is a site, again, a little over almost 3.5 acres was undisturbed, had about 2.25 acres was being disturbed. It's going to this sediment basin, it's discharging. This is a little side road and there's no drainage on this side of the road. So there's drainage on the other side. So we had to control our peak rates going out so we didn't increase or cause any hazards worse than what was already existing on that road. Kind of surprised they didn't make us pipe under the road and tie it in, but that wasn't required. So, just going through the modeling, got your 5.5 acres, curve number of 59 for existing wooded conditions, time of concentration just below 20 minutes for the site. The post, the portion that's not being disturbed obviously would be the same. The disturbed area is at 2.25 acres. We used a curve number 86 for a disturbed bare earth condition and reduced that time of concentration about 7 minutes for that. So when you're building your basin, so this is in your stage storage chart, what you need to do is you need to build in points for you to plug in your skimmer flow. So in this case, we built in a basin that had a 0.1, 0.3, 0.5, and then 1/2 foot increments up to 4 feet deep. In this case, the basin was 4 feet deep. It could be deeper. But we put these in to give us a point to be able to manage our discharge later. So all of our skimmer details include flow rates. And again, this is the tested, third-party tested flow rate. So this is at that 0.1, 0.3, 0.5, and then every 1/2 foot up to 4 feet. The test tank was 4 feet deep, so it's limited there. And then we provide an average flow rate, which is basically from 6 inches to 4 feet. You kind of discount that bottom 6 inches since it reduces there. But you'll have that for every orifice configuration for each skimmer. And all of our skimmers come with standard orifices. Some of the other skimmers out there have a plug that you're supposed to cut to a certain size. We don't do that. We just, since we third-party tested all of ours, we just provide a range of orifice configurations, typically, 3 to 4 sizes per skimmer. So then when you're building your outlet structure, you have your barrel going out. So it's your 18-inch pipe going out. In this case, it was kind of a complicated outlet structure for a small basin, but it had a 6-inch orifice that was 1.75 feet above the invert of the main barrel. Had a riser structure. So the riser is 3.6 feet tall, and it had a rectangular weir at the top of the riser, 3 feet above the bottom. And then to put in your skimmer flow, you use this user-defined column. So this is the one thing you may or may not have used before, but this user-defined flow, based on the stage, you're plugging in the flow rate at each point. And so you use that based on our details to plug that in, and that will build the flow rate curve for the skimmer. So, you'll see that the total outflow is just the skimmer flow rate until it gets up and starts hitting the other orifice openings. If your pond's over 4 feet deep, you have two choices. You can either just maintain that 4-foot flow rate. If you remember the flow rate curve chart I showed, typically most of the skimmers have flattened out around 4 feet deep, or you can extrapolate it, based on the last 2 or 3 points. You just kind of use your engineering judgment to go up. You can see it's not going up very much in the last couple of points. So, and then if you look at your outlet structure in HydroFlow, your schematic, you'll notice normally you'll have a low flow orifice down here at the bottom. You don't see that here because of that user-defined flow rate. You do see the 6-inch orifice, the rectangular weir, top of the riser, all going in there. And so this is your stage discharge curve. Again, this is your skimmer flow here. Then that 6-inch orifice kicks in, then the rectangular weir kicks in, then the top of the riser. And just to show a little better, this is your skimmer flow, this green line. You can see it's a very small percentage of your overall flow, especially when the pond gets deeper. And then again, once you run everything, you can double check in the table just to make sure your flows are accurate. And again, it's just the user-defined flow until all the other orifices kick in. And you can see the stage at which those kick in along here. So in this case, we had a 2-year storm event. Our pre was 2.3 CFS. Post was about 2.5. City allowed about a 0.2 CFS increase in the 2-year storm. But for the 10-year storm, we had about a half a CFS decrease. Now, the city of Greenville requires us to run SEDCAD calculations to calculate sedimentology rather than just having a standard volume. You can have a standard volume, but it's usually better if you run the sedimentology, a smaller basin. But they did not really require a minimum time frame for drawdown. And so if you check that, if you look at your stage discharge or hydrograph going out, the pond fills up around the 12-hour mark of the storm, and it's basically dry, by 30 hours. So your 18-hour time frame from full to empty. So obviously you're not hitting that minimum 48-hour time to drain the basin. So if you do have to do that, first we check, make sure that we were filling up our basin. Well, yeah, it's getting pretty much all the way to the top of the riser, in there. So we changed that. We went back and we remodeled it with a smaller skimmer, and we did hit that then time frame. So we got out to 66 hours overall time. And if you really got nitpicky on it, it really didn't fill up till 12, but still 66 minus 12, you're still at 54-hour time frame. So you met your 48-hour minimum. And again, we had to keep our freeboard and all the other kind of requirements in doing that. But when we did that, our peak outflow actually went up. So a little contrary to what you're thinking, you got a smaller skimmer, you're thinking you're probably going to have less flow. In reality, because the smaller skimmer, the water got higher in the basin, so it hit some of the other outlet structures, the top of the riser, maybe even hit emergency spillway. And so our flow rate actually went up. So had they required us to meet the 48-hour time frame, we would have had to build a larger basin to control more of that volume before, in order to keep the flow rate down. So just something to be aware of. Smaller skimmer doesn't always mean lower flow rate as far as peak flow. Any questions on hydroflow and modeling there? That was a little quick on that. All right. So the other software that we'll touch on is HydroCAD. I'm not sure if you're familiar with HydroCAD. It's pretty similar to HydroFlow. We had a project in Charlotte that we were doing, and the reviewer, we kind of had our pre-submittal meeting, and the reviewer mentioned that they were not a fan of HydroFlow for some reason, but they really liked HydroCAD. So what do you do in order to get through the review process? You give them what they want. So we went out and bought HydroCAD. So again, very, very similar program. A lot of similar inputs, slightly different look, but pretty similar thing. It does have a slightly smaller report generated. So if you want to save some paper, although thankfully now we're doing electronic submittal, so you're not having to print out 200 pages as much. But anyway, the one difference in this is HydroCAD is a much smaller company than Autodesk, obviously. And so they are more inclined to incorporate proprietary products. And so they have this special and user-defined outlets. So whenever you're building your outlet structure, you just put in that you want to use one of those. You click this button, load from file. That goes to a list of folders that'll have a variety of proprietary products. They have the Marley float built in there. And so instead of having to manually enter the flow rate, at 0.1, 0.3, 0.5, so on, you just pick whichever skimmer you want to try with whichever orifice. Now these are our old models. The latest version of HydroCAD does have the new models in it. We also, if for some reason you have a version that hasn't been updated, those files are on our website for download, as well as instructions on how to use HydroCAD. But anyway, really the benefits of it are save you some typing, less chance typos. It has a discharge multiplier. So if you want to try it with 2 skimmers or 3 skimmers, you can change that. It will also extrapolate flow for over 4 feet to make it, instead of you trying to calculate it, it'll extrapolate it for you. Again, if you need to check your time frames, you have to change your time span settings out to a longer time frame. And then you just click this node report on your pond, and it'll give you that same discharge hydrograph, show you the time frame of when it's being discharged out. So again, no, I'm hitting that pretty quick, but if you have any specific questions on HydroFlow or HydroCAD, please feel free to email me. Be glad to get back with you, or even jump on a quick video call and kind of go through any specific challenges you're having as you try to model those. So give you a couple of things about Rymar specifically, and we'll talk about one of our other products as we wrap up here. This is our website. There's no login, sign up. You're not going to get spammed, to download any of our information. If you're looking for Marley float stuff, you just go to the by product, Marley float, and there's a spec page that has most of the information you'd like to have. You'll get to this. We have a design tool. That tool is for ponds without a permanent pool. Then we have a basin with permanent pool design, based on Ohio specifically. We have a comparison chart. If you want to just see how our flow rates and cost compare to the Faircloth skimmer, that's there for you. Then we have all of our skimmers, the details and cut sheets. Details are in PDF or CAD, so you can edit as needed for yourself. And if you scroll down this page, I don't have it on the slide, but if you scroll down this page, you also have our skimmer basin details, which we touched on earlier. So a couple things about our details. Again, we've touched on that each detail includes the skimmer and each orifice configuration that the skimmer has. It has a third-party tested flow rate from 0.1 to 4 feet and the average flow rate. Our skimmers come with an orifice plate that goes inside this area here. And so I've got a slide, they'll show this a little better, but each orifice plate has different size orifices cut into it, and you just rotate that plate to align with your outlet, to adjust your flow. We recommend that the pipe from the outlet structure to the skimmer be around 1.4 times the height of your riser structure. We provide a flexible coupling. It's different than most other skimmers. If you're familiar with a fern toe type coupling, it's basically one of those with bellows in it. So it's designed to flex, actually about 135 degrees it'll flex. It'll easily flex 90, going up or down or to the side if you need to pull it over for inspection or if it's clogged. But if you do a 1.4 times the height of your riser, that means the skimmer will always float up high enough so that it won't top, if water does top your riser structure. A couple of things about our product is we are an HDPE product. So it is very UV resistant, is, virtually indestructible. We have had them left in basins in Northern Ohio that have had, severe freezes, left them in the entire time. They have not cracked. They've not been broken. They've not really been damaged. We had one skimmer down in Alabama get swept out of a pond when the dam broke because of a hurricane. They found it a couple of 100 yards downstream, picked it up and put it back in place, and it was still functioning. So very, very doable product. And that's one of the reasons we do recommend it for permanent use as well as temporary. Again, we have this debris guard kind of skirt around it. So it helps prevent the clogging. Flow comes under that guard. It's not really, it will come through it, if it's sitting on the bottom or needs to, but most of the flow is going to come underneath. So it's going to eliminate anything from coming off the surface. It's going to help trap the floatables in the basin. And the only thing that touches the mud is the bottom of a round pipe, which you can see here. So it does not get stuck. And because it's taken from below the surface, it will work at least in mild frozen conditions. Now, obviously, if you get a foot of ice, it's gonna stop flowing. But in mild frozen, 3, 4, 6 inches ice or less, it should continue to work fine. This is video, hopefully you can see this coming through on here, that shows our Orifice Plate. So we have this little metal, I think technical term is nub right here that the orifice goes on. So that helps make sure that the outlet is centered over, or the hole is centered over the outlet structure. And you can see how simple it is. Just pick it up, turn it, rotate it, get it to the right size, put it back in, and it's placed perfectly. So that comes with each skimmer. Each model has 3 to 5 flow rates in each device. We have 6 different models of skimmers to choose from. And again, all of our flow rates are third-party tested to verify. I don't know if you're familiar with our previous models, but our previous model was a little top heavy and it had some issues if it wasn't installed correctly in turning or twisting. So we redesigned the skimmer about 2 years ago and relaunched it. And this is our new model. You can see in our test tank, no matter what you do to it, it always returns to float level, does not tip or twist or sink in there. So anyway, it was been thoroughly tested before we relaunched it. This is the float for our 6 and 8 inch skimmers. Because we are holding this outlet pipe below the surface, in this case, most times you got a 6 inch outlet pipe, a 20-foot piece of 6 inch pipe is going to really have a lot of buoyancy. So these skimmers are weighted about 200 pounds each to hold that pipe down below the surface. So we had to have a specially designed float in order to make sure that it also did not sink. We built in handles to make it easier in the field to handle. And if you do decide to put these in permanently and say it's a high-end subdivision or something, they really don't want a orange float out in their pond the whole time, we can do custom colors in this product. Because it is a custom made for us, we can do a variety of colors to help it blend in with the water better if that's desirable. It does take a month or 2 of lead time to do that. So if you'd have one of those, just let us know ahead of time, but we're glad to work with you on that. This is our different models and the different flow rates. So we go from our 2 inch with a 1/2 inch orifice, which has a trickle of 250 cubic feet, to our standard 8 inch. Our standard 8 inch uses a 6 inch pipe as outlet. It has a flow rate of up to 1.5 CFS, which is still higher than most other skimmers on the market. We also have what we call our 8 inch with 8 inch pipe, or 8 inch max, has a flow rate of over 1.8 CFS. So if you've got a really large site that maybe needs 2 8-inch standard skimmers, you might be able to use just one of ours for that, and it'd be much less expensive and a lot easier to install. This side has not been updated. We did just recently have a slight price increase. Just like everybody, we've been hit by our suppliers and raising the price materials that go into it. So we've had to make a slight increase on that, but we're still very competitive with other skimmers on the market. And the other thing we're really excited about, want to make you aware of, is we have research underway to test filter media around the skimmer for post-construction to remove TSS, metals, hydrocarbons, and other pollutants. So this is that pond I showed, that former car dealership area. So we've now replaced the skimmer there with our new model. We put this filter in. The outside is a woven monofilament screen to take out all the big stuff. Inside is a non-woven kind of a filter fabric to take out the other pollutants. It's designed to absorb hydrocarbons. It can actually be treated with a substance that helps control bacteria as well. So we are monitoring this. This has been in place since March of 21. So we go by there on a regular basis after each rain event. We also have installed a time-lapse camera to kind of help monitor things. You can see the basin's pretty nasty. It's got a lot of junk and debris in it. This was probably during a time when we had a lot of pollen there. So, it's a good test case. If it'll continue to flow here and not clog in this basin, it's going to work just about anywhere. Interesting, the non-woven material filter fabric has started to grow vegetation. This left picture was in July, and then by mid-August, you're sprouting some pretty good vegetation out of it. We're actually thinking we may try to encourage that and use that to help remove nutrients, phosphorus and nitrogen. I know you probably heard of floating wetlands or may have seen those. We're not sure exactly how that works. So far, it does not appear to affect flow rate. So we were concerned about it initially, but I actually think it could end up being a good thing. And again, here's the outlet there. A little hard to see, but you can see it's fairly clear water. So, fairly turbid water in the basin, fairly clear water coming out. It does help with turbidity. It definitely helps with TSS. We're actually, just so happens, meeting with our testing company this afternoon to get our third-party testing scheduled to confirm our TSS removal. So hopefully they'll have that completed within the month or so, and look to hopefully launch this product to make it available first quarter of 22 for design. So we'll give you design specs on how it can handle. Really excited about this because it's going to change how you design detention ponds. Instead of having to design your pond for a volume that's drained over a period of time, 24 to 48 hours, which obviously results in that really small low flow orifice, you'll be able to design your pond to allow a higher flow rate, basically to whatever your first quantity control milestone is. So let's say that's a 2-year storm. You can, pick a skimmer combination with a filter that can treat water at that same flow rate as your 2-year storm flow rate. What that'll do is it'll greatly reduce the volume of your pond. So your pond will get smaller. We're estimating 25 to 30% smaller pond volume. It will treat 100% of the rain events below that storm event. Currently, if you get a 1/4-inch rain, right, you get no ponding in your pond. So, all the pollutants in there flow straight through and straight out for the most part, except for whatever maybe vegetation filtering they have. Well, in our case, all of that flow, whether it's a 1/4-inch rain or whatever your water quality event is, maybe 1.5 to 2-inch rain, 100% of that flow would go through the filter and be treated. And then thirdly, easy to maintain. You can get to it, you can monitor it, you can make sure it's working. So stay tuned for that. We'll be sending out information, hopefully first of the year with more details there. So lastly, as we wrap up here, I do want to introduce one other product we have. So this is what we call our Wattle HS, or hard surface model. So I believe in your area, when they build subdivisions, they leave off the final asphalt surface during construction of the houses. So what happens is you try to put something in your out there to catch sediment and also get the water into the catch basins. In our area, they use the erosion eels, which unfortunately, this is what they often look like shortly after they've been in place. They get hit, they bust, they leave rubber everywhere, and they're not really effective. Or worse, they put them around the catch basin and it totally blocks any flow from getting to the box. If you've got a stretch of long road down to a low point, that can be a disaster because all the water is going to bypass and it's going to end up overtopping your low point. So we've developed our Wattle. It's foam filled. It is screwed down. We've got a really coarse threaded screw to go down the asphalt or like a standard tap con on the concrete. It's designed to capture sediment. It's just a secondary sediment control. It's not your primary. We don't have 80% trapping. We just don't have enough volume here to meet that, but it's a nice secondary containment. But the main purpose is it kicks water over the curb into the catch basin. And so your box actually works. So you can see here, this is after a rain event, all the water is in the asphalt, very little in the curb. If this weren't here, it's shooting right by that catch basin going down to a low point. With our Wattle, the foam kicks up during the rain. So before it lays flat, see here it's kind of inclined a little bit. So you get a little higher barrier there. It's kicking it over the edge of the curb, and you leave a gap between the end of the wattle and the curb so water can flow through there and get into the box. Again, it's foam filled, so it's designed to be driven over. It could be a car, sports car. Again, when it's not raining, it's laying down. It's really low profile, so it's only sticking up 2 or 3 inches above your asphalt. There we go. Or it can be run over by a dump truck. This was one of our original prototypes in a really high traffic area. It had been in place for probably 3 or 4 months when this video was taken, but you can see it's still functioning well, pops right back, capturing a lot of sediment. It does need to be maintained. You have to, take a shovel out there and scoop it out. We do get asked about snowplows. This is not going to hold up to a snowplow. So if it's in an area where you're going to have to plow the road, it will not be your best option, at least during that time of year. You need to take them out and probably put them back. We've seen some people go out and try to clean them out with skid steers. That doesn't work either. They're not designed to handle that, but they'll handle being driven over, not scraped with a skid steer or snowplow. So that hits us almost exactly 1 o'clock. So I managed to hit your time frame well. I really appreciate you joining us today. If you would like to have a PDH certificate, simply email myself, Barbara. The email address is info@rymarwaterworks.com. My personal email is Jamie, Jamie, @rymarwaterworks.com. We'll get you a certificate back out. I will mention Barbara's on vacation for a week or so, so we may run behind getting those to you, but I promise we will get them to you. And if we can be of assistance on your projects, have any other questions, we'd be glad to do that. And we would greatly appreciate it if you would consider specifying the Marley float on your next project. We are available in Ohio. Core and Maine, Ferguson, and Site Supply are all distributors for us, so we're very readily available. Most of those guys keep skimmers in stock, so contractors can get them very quickly in your area. And if anybody has any questions, y'all have all been very quiet, so hopefully I haven't bored you too much.
No, super informational, so thank you.
Okay, thanks, Derek. Okay, well, y'all all have a good day. Anything comes up that I can assist with, please don't hesitate to ask, and just appreciate you joining us. Thanks.
Thank you.
Thank you.
You're welcome.